Welcome to Get Your FRQ On. This question is from the 2002B Calculus AB exam, question number 6, and it is not a calculator active question. In the question stem, we're provided with a figure and a situation where two boats near a lighthouse traveling on perpendicular paths, and that sets up the three parts of this free response question. In the first part, we are asked to find the distance between ship A and ship B when ship A is 4 kilometers from the lighthouse and ship B is 3 kilometers from the lighthouse. Since the two paths of the ships form a right triangle, we can use the Pythagorean theorem to determine the distance between them. So the distance between them is the square root of 3 squared plus 4 squared, which is the square root of 25, which is 5. So the two ships are 25 kilometers apart at that time. All right. One thing to understand about free response questions is you need to be in the habit of providing the correct units. Sometimes the question will ask and specifically state give the correct units or something like that. Other times it might not. It's just a good habit to get in to provide the correct units. It could very well cost you a point. Probably not more than that, but maybe if you don't have the correct units. One of the things about doing the calculus is understanding what it is you just found. So providing the correct units helps us determine what it was we just found. For part B, in this free response question, we are asked to find the rate of change of the distance between ship A and ship B. And since we know that distance is calculated using the Pythagorean theorem, we can apply implicit differentiation to that formula for the Pythagorean theorem and derive some expression for dr dt if r is the distance between those two ships. So we take the expression r squared equals x squared plus y squared, and we apply implicit differentiation. Differentiating that expression, we get 2r dr dt equals 2x dx dt plus 2y dy dt. And since we already know at the time in question x is 4, y is 3, and r is 5, we can substitute all of that information in and solve for dr dt, since we also know dx dt and dy dt. All right. In the question, we're given that dx dt is negative 15 kilometers per hour and that dy dt is 10 kilometers per hour, but we also just found the value of r in the previous part of this question. So if we substitute all of that in, we can figure out that dr dt is negative 30x plus 20y all over 2r. All right, continuing to fill in the information that we know using x equals 4, y equals 3, dx dt equals negative 15, dy dt equals 10, r equals 5. Plug all that into that formula that we just found, and eventually we conclude that dr dt is negative 6 kilometers per hour. Also in the question stem, the angle theta is defined as the angle between the lighthouse, ship A, and ship B. So the location of ship A is actually the vertex of that angle. And we are asked to find d theta dt when x is 4 and y is 3. Based on the definition of theta, we can state that the tangent of theta is y over x, using a trigonometric identity there. D theta dt would be related to tangent theta. So if we differentiate our equation tangent theta equals y over x implicitly, we get secant squared theta d theta dt is equal to, and then on the right side, since we have y over x, this is actually an application of the quotient rule. X dy dt minus y dx dt all over x squared. And then we can solve for d theta dt by dividing both sides by secant squared theta. So plugging in everything we know, we get 85 over 16 secant squared theta. Given the definition and the distances provided, secant theta is 5/4. So we can then plug 5/4 in for secant theta, square that, 25/16. And eventually we get 17/5 radians per hour. And again, unless otherwise stated, on the AP exam, we're typically dealing with radians, unless an image or a picture in the free response question specifically indicates, or a text in the free response question specifically indicates that we should be working in degrees. You should assume that we're working in radians. So the correct label here would be radians per hour. And that is the solution to question 6.